All right. Now, the last part of this looks at not endoderm, not mesoderm, not ectoderm, but kind of a combination of all of these germ layers and how they form what we call the extraembryonic membranes. These are the membranes that are necessary for development, but are not part of the embryo proper, as we call it, which is essentially what makes up you and I. So various organisms have different combinations of things. In fact, they're different depending upon whether you're a bird or a reptile or a mammal, whatever the case may be. But there are some things that no matter what organism, as long as we belong to the amniotes, then we have various things in common. For example, birds and reptiles and us, we have an amniotic sac. And so the amnion and the chorion come from a region called the somatopleur. And the somatopleur is actually a combination of both ectoderm and mesoderm. It's from the somatic lateral plate mesoderm and the ectoderm in which you get the formation of the amniotic sac. So birds and reptiles and mammals, we all develop essentially within an amniotic sac where it fills it with fluid so that we can develop properly. Chorion, in us, that's the placenta. So we don't have the same type of chorion that birds do. Now, for birds and such, they will have the chorion attached to the eggshell, and that's where they get gas exchange. So we get our gas exchange through the placenta, through the mother breathing in and out and bringing that oxygen to the placenta. But as far as birds go and reptiles and whatnot, that's going to fuse with the eggshell, and so the outside air is just going to diffuse in through the eggshell into the chorion and be brought to the embryo itself through that region. So there's obviously no placenta in them because they're not mammals, but it serves the same purpose essentially, and it comes from the same region. Now, the yolk sac, which surrounds the yolk, as well as the, I always mispronounce this, Atlantis, right? Atlantis? The Atlantis and the yolk sac, I always want to say Allantois, but it's not. It's Atlantis. The yolk sac and Atlantis comes from both the, where is it? Comes from what we call the splanchnopleur, which is mesoderm and endoderm. So there's a combination of mesoderm and endoderm. The splanchnopleur essentially will surround the yolk, and that's what becomes the yolk sac. And this is where you're going to get the nutrients being broken down in the yolk. The embryo doesn't actually absorb the yolk itself. It breaks the yolk down into amino acids and the necessary components, and then filters it through the bloodstream to bring to the embryo itself. So it doesn't actually bring the yolk to the embryo, but it brings the breakdown of the yolk into the necessary basic biological molecules that the embryo needs. The other region is called the allantos. Now, the allantos is primarily for storage of waste, and when you're dealing with a bird or a reptile in an egg, it doesn't get rid of the waste, so where does it put it? It puts it in this region. The allantoic membrane stores a lot of the urinary waste and such during development. In chickens, you actually get a combination of the chorion and the allantos, and you get what's called the chorioallantoic membrane. So you get this membrane that not only fuses with the shell for gas exchange, but it also is necessary for transporting calcium from the egg for bone development, as well as for muscles and things of that sort. So as the embryo continues to develop, it will pull calcium, and that will actually cause the egg to become weaker and weaker, so that when they get time to break out of their shell, it's much weaker than what it initially started with. So that's where they get a lot of their calcium from, is the actual shell itself rather than from the yolk area. So this just kind of shows, here we have the somatic mesoderm and the splanchnic mesoderm. This is all the lateral plate mesoderm. This region right here we call the somatopleur. This region right here we call the splanchnopleur. So here, this is what will eventually become the amnion and the chorion. Over here, this is what's going to become the yolk sac and the allantos. So this one right here, this is the one that you should probably pay most attention to because it illustrates each one of these regions. Here's the amnion, which will form the amniotic sac around the embryo. Chorion, you can see this is on the outer region that will fuse with the shell that will, for gas exchange. We have the yolk sac, which surrounds the yolk and supplies the nutrients to the embryo itself. And the Atlantis, which is waste storage, essentially, for the embryo, especially that are in eggs. The placenta for us, the chorion, essentially does all of that in terms of the nutrients and waste and gas exchange and whatnot. Even though we have a yolk sac, we don't have yolk. So our nutrients obviously come from the placenta or from the mother, and we'll take whatever we need from her, even at her expense. So here just illustrates the placenta and the umbilical cord and that role that it plays in us, in mammals.